Okay, the majority of this is going to be reviewed just like we did when we started this unit with triangles. So how would you find x? So take 180 minus 90 minus 65, or add 90 and 65 and subtract it from 180. Right, okay. How would you do? How would you find the missing side there? Pythagoras, right? If you know two sides, you can find the third side of a right triangle by using a squared plus b squared equals c squared. How would you find the missing side here? Can you use Pythagoras? Yes, no? Why not? Because we only know one side, right? So I can't use Pythagoras, so I need some sort of other method to find it. And that other method that helps us find missing sides and angles, depending on the information we're given with, is trig. Okay? So this is just a review of trig, and then we're going to talk more about how we can apply it. Because that's what we're more concerned with. So this was done in grade 9 if you're in the accelerated, in grade 10 if you were in the regular stream, where we learned about 3 trig ratios that helps us find missing sides and missing angles in right triangles. And those ratios are sine, cosine, and tangent. Okay? And the sine of an angle, okay, so a right triangle is made up of a right angle and 2 acute angles. Okay? So we've got a right angle here, we've got an acute angle here, and we've got an acute angle here that's labeled, and many of you should be familiar with this, but if you're not, that little 0 with the slash through it is the Greek letter theta. And it just, usually we use that letter to represent an unknown angle. So using trig, we name the sides of a right triangle depending on the acute angles we're talking about. Okay? So if I'm talking about this angle, the hypotenuse, okay, how do you find the hypotenuse in any right triangle? It's always the longest side, or it's the side that's opposite the right angle. So if you start at the right angle and draw an arrow out, the side you're going to hit is the hypotenuse. Okay? To find the side that's here in relation to this angle, well, if we draw an arrow out from this angle, we hit the opposite side. And the third side, which we usually just get by elimination, is called the adjacent side. So this would be the adjacent side because it's beside this angle. That's how we name the sides. Okay? So if I said, what side length is opposite C? 7. Because from C, if we draw an arrow out from C, the side that we're going to hit is the opposite side. What side is the hypotenuse? 41. What side is adjacent to angle A? Right. How do you find the adjacent? Well, we know this is the hypotenuse. If we draw an arrow out from A, we're going to hit the opposite side, which means by elimination, this must be the adjacent side. Okay? Once we know those sides, then we can use ratios of the sides and certain trig ratios to find missing sides and angles. So in a right triangle, the sine of any acute angle is always the ratio of the side opposite over the length of the hypotenuse. The cosine of the angle, this angle, is always the ratio of the side adjacent over the hypotenuse. And the tan of this angle is always the side opposite over the side adjacent. So we're going to use one of those three trig ratios depending on what information we're given in the problem and what information we're asked to find. Okay? So for here, you can see in this triangle, for angle A, for the sine, it's opposite little a over hypotenuse C. For the cosine of angle A, it's the adjacent side, which is called B, over the hypotenuse C. And for the tangent, it's the opposite side A over the adjacent side B. And we would do it similarly if we were referring to angle B. How do you remember those? You guys should know, remember this. SOHCAHTOA. That's how we remember the names and the sides. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan or tangent is opposite over adjacent. And you should all be familiar with that. Okay? Like I said, this is just kind of a quick review. A little bit of practice before we get into some more complicated questions. Okay. So let's do some examples. Here we're given a triangle, A, B, and C. We're given the three side lengths. We are asked to find the sine, the cos, and the tan of angle A. So that means our answers are going to be fractions. We're not asked to find angle A yet. We're just asked to find the sine of angle A. Well, what's the sine of angle A? The sine of, it's the opposite side to A over the hypotenuse. What's that? Okay. So what would it be? 4/5. Because the side opposite angle A is 4, hypotenuse is 5, so it's 4/5. The cosine of angle A is 3/5. Just put this one down here. And the tan of angle A is opposite side over adjacent side, which is 4/3. And then to find the sine, cos, and tan of angle B, we just do the same thing, except now we're talking about angle B, which means the opposite side and adjacent side are going to switch. The hypotenuse is still 5, but the opposite side is now going to be 3, and the adjacent side is now going to be 4. So we would say that the sine of angle B is 3 over 5, because it's opposite over hypotenuse. The cosine of B is 4 over 5, and even the tan flips. Instead of 4 over 3, it's going to be 3 over 4. Okay. Okay, so basically, we set up an equation using trig ratios to find missing angles or missing sides using trig. And there's 3 situations. Okay, one, because when we set up a trig ratio, there's 3 pieces of information. There's the trig and the angle on one side, and then there's, on the other side, one side length over another side length. You're always going to be given 2 out of the 3 pieces of information, and then you use algebra to find the third, which is essentially what this says here. Okay? So how do we find missing sides and missing angles using trig? Okay, enough. Stop it. So here we're given a triangle, right triangle. Can't use Pythagoras. We can't use sum of the angles is 180. So we're going to have to use trig. But we got to set up our trig equation. And remember, the trig equation always looks like this. It's going to be one of the 3 trig ratios, then the angle equals some side length over another side. That's the framework is how it's always going to set up. We're going to know 2 of the 3 pieces of information, and we use algebra to solve the third, or find the third. So in this case, this is the angle I'm dealing with, 25 degrees. What's the name of this side that I'm trying to find? Like the name of it, opposite, adjacent, or hypotenuse? From 25. Opposite side. What's this side length? Hypotenuse. So opposite and hypotenuse tell me I have to use sine. So my trig is going to be sine. My angle is going to be 25 degrees. My top side is going to be the opposite x over my bottom side, which is going to be the hypotenuse 11. You can always construct an equation, and then when you do, use algebra to solve. So for this one, I look at this and I see, okay, I got a fraction. How do I get rid of divide 11? Multiply by 11, which means I got to do this to this side. So what does that tell me? That tells me that 11 times the sine of 25 degrees is going to get me my missing side x. And now, of course, in the last step in trig, no matter which one we do, you're going to need a calculator. So to find the missing side, I would do 11 times sine of 25. And what was I asked to round to? 2 decimal places. So if I do this properly on my calculator, I should get 4.65. So that's how we do it for all of these. Figure out what trig ratio, set up the equation, solve. So that's one example. That's one type where you're given an angle and a side and the missing side is on top of the fraction. Another example would be this. So I got to set up my equation. What trig ratio am I going to use? Here's the angle I'm referring to. What's the name of this side? Opposite. What's the name of this side? Adjacent. Opposite over adjacent tells me I'm going to have to use tan in my equation. Following the trig comes the angle that you're working with. In this case, it's 68 degrees. Equals opposite side to 68, which is 8, over adjacent side, which is y. There's my equation. Little bit different because this time the side length, the unknown side length, is on the bottom. But I still solve it the same way. I want to get rid of the fractions. So how do I get rid of a divide y? I times y. So I get y times tan 68 degrees equals 8. Notice I still don't have y by itself. There's a times tan 68 with it. So how do we get rid of a times tan 68? We divide tan 68, and whatever you do to one side, you do to the other. So that means to find my missing y, my missing side length on my calculator, I have to do 8 divided by the tan of 68 degrees. So 8 divided by tan 68 is going to give me, to 2 decimal places, 3.23. Is that your assignment? It's okay, thank you. Okay, the third situation, when you know both the sides, but the angle's unknown. So like this. We're still going to set up our trig equation, but it's going to look a little different. Okay, what's the acute angle I'm dealing with? It's the one called x. What's the name of this side, the 5, in relation to x? Opposite. And this side, which tells me I'm going to use tan of the angle, which is just x, equals opposite side 5 over adjacent side 13. So now the equation looks a little different. This time the x is the angle. But we still solve it using algebra. Remember, this does not mean tan times x. Tan is, you got to think of tan as an operation. Like if I said find the square root of 9, you wouldn't go square root times 9. Doesn't make sense. The square root is the action. So how do I get rid of just a tan? I can't divide by tan. How do you cancel out a tan? Do you remember? Tan inverse takes them out. And whatever you do to one side, you've got to do to the other. So tan inverse of 5 divided by 13. Now you got to go to your calculator again, and this time to find tan inverse, it will be above the tan button, so you have to go second tan, 5 divide 13, and that will give you, it said nearest degree, so nearest whole number. So therefore, the unknown angle is going to be about 21 degrees. This is all, again, like I said, this is all review. Now we're going to start going into sort of like how can we apply it? And basically different types of situations where we can apply trig. Okay. But before we do that, I would like us to tackle this question. We're not going to do examples 5 and 6 are the same, basically. So I'm just going to do one of them. So here I have given you a right triangle. I've told you that one of the acute angles, and I've told you one of the sides. Given just that information, you are asked to solve the triangle. When you see that instruction, solve, that means find all missing sides and angles. So not only can we use trig, but we can use also what we did earlier in this unit. If we add 3 angles up, they add equal 180, or we could use Pythagoras. So the first thing you did, well, I know 2 of the angles, so why can't I just go ahead and find angle A by subtracting these 2 from 180? I don't have to use trig. So for angle A, we can just do 180 minus 90 minus 50.4. What did that give us again, Anna? 39.6 degrees. Okay, so that takes care of all the angles. So I'm going to double hash that baby just because that's one of the final answers. Now I got to tackle the 2 missing sides, which means that I could use Pythagoras or I could use trig, but I can't use Pythagoras unless I know 2 sides. So my next step is going to have to be trig. What side do you want to find? Doesn't really matter. Let's find B. Well, how could we find B? There's all sorts of ways because I know both acute angles. Like I could say, all right, well, if I use this angle, then the tan of 39.6 equals 17.4 over B. Or if I use this angle, I could say the tan of 50.4 is equal to B over 17.4. Both will give me the exact same answer. So for B, I'm going to use tan. I'm going to use, or sorry, yeah, tan. Opposite over adjacent. So tan of 39.6 degrees equals the opposite side, 17.4, over the adjacent side, which is B. And now I start solving this. So get rid of the fraction, times both sides by B. And I get B times the tan of 39.6 degrees is equal to 17.4. To get B by itself, I have to get rid of the times tan 39.6 by dividing tan 39.6. And I have to do the same thing to the other side. So that's going to give me an answer of B is approximately whatever 17.4 divide tan 39.6 is. 17.4 divide tan 39.6 gives us, what were we asked? 1 decimal place, I think. Oh no, it doesn't say. We'll just go, actually, if you do it, you're going to get about 21. You get 21.0 something. So you can just leave it as 21. So now we got this side. This is 21 centimeters. So the only thing left to find is side C. And again, you've got a ton of options. You can use Pythagoras if you want, because you know two of the sides. You could do trig with this angle, and this side or this side. You could do trig with this angle, and this side or this side. And all of them are equally correct. So I'm going to do trig again. I'm going to use this, and I'm going to use opposite over hypotenuse. Remember, this was opposite over adjacent. So to find C, I'm going to use sine, just because I like to use trig. So sine of 39.6 degrees equals opposite side 17.4 over hypotenuse, which is called C. So sine 39.6 degrees equals opposite side 17.4 over hypotenuse, which is C. And then we solve this one, and then we're done. Times both by C. And I get C times sine 39.6 degrees equals 17.4. Divide both sides by sine 39.6 to get C by itself. And C will work out to approximately 17.4 divide sine 39.6, 27.3 centimeters. So there's the three missing pieces that we had to find. Okay. I'm not going to do the next example just because it's very similar to what we just did. The only difference is I didn't give you a drawing of it this time. So sometimes you're going to actually have to draw. And you want to make sure that you draw accurately. Such as this last example. This is the one I want to look at, the final one I want to look at. Anyone know what a brace cable is?
Anybody know what?
Brace cable.
I think so.
Okay, what do you think?
Isn't that when you put a cover over your house for the TV?
Okay, yeah, well that's the antenna. A brace cable would be like this. A brace.
Oh, like a thing like gray, right?
Yeah, yeah. What it does is it keeps the antenna straight. Yeah, you're right. Yeah. So in this example, we actually have to draw the situation before we can actually do the math to answer it. So a brace cable is needed to support a satellite antenna that stands vertically on a horizontal roof. Okay, so here's the roof. We know that it's horizontal. There's an antenna on the roof, and it's vertical. What does the antenna look like? Isn't it kind of like a half moon kind of thing? Like that. The brace cable keeps this antenna vertical. It keeps it from falling. So it's going to be something like this. It's going to attach near the top of the antenna, and then somewhere else on the roof to hold it in place. Out of this situation, we have created a right triangle. Because the antenna is vertical, the roof is horizontal, that means they must meet at a right angle. Now we just got to figure out, where do we put our measurements? Oh, actually, oh, I see. Okay, so I didn't draw this quite correctly. It should go like this. Because the brace cable goes right, a lot of times it doesn't go right to the top. It'll go part way up. It doesn't have to go all the way to the top. So where's the 35 feet here? What represents 35 feet? Here? Yes. Because that's the height of the antenna. The bottom left angle is 68 because we're asked, remember, this is the cable. What angle does it make with the roof? So one arm is the cable, the other arm is the roof, so therefore 68 degrees. And what is that we're actually asked to find? Well, this is what we're asked to find, the length of the cable. So that's our X. So again, this is something that you should be familiar. What's that? Oh, we're figuring out the length of the cable. Oh, so you're telling me this is 22. Yeah, that's fine. You're right. And you could use it if you wanted to. Okay. So you got to make sure you got to be able to draw a situation like this. That's sort of one of the big things I want you to get out of this unit, is be able to draw a situation. Thank you. That's how we're going to find the length of the brace cable. Because if this is the angle, this is the opposite side. This is the hypotenuse, which tells us so, which tells us sine. So now we do the algebra again. Times both sides by x to get rid of the fraction. We get x times sine 68 degrees is equal to 35. Divide both sides by sine 68 degrees. Divide both sides, divide this side by sine 68 degrees. So x is going to be 35 over sine 68 degrees, and that's when we pull out our calculator. And it doesn't ask us to round it to anything. If it doesn't ask you to round it, one decimal place is usually safe. 35 divided sine 68 is going to give you 37.7. And don't forget your units, that's feet. So that's the length of the brace cable. Okay, so there are similar questions in exercise 3.2. There's two questions where you have to solve a right triangle. Only do one of them. Don't do both. Okay, you don't need to do both of them. Because again, that's kind of review, because we also kind of did that in grade 9 if you're accelerated, grade 10 if you're in the regular. Okay. So next step is we can take this even further with angles of elevation and depression and diagrams that involve multiple right triangles, which again, many of you have seen. Okay. But I also want you to be able to draw certain situations. Some situations I'm going to give you the drawing because it's a little bit too complex to draw from the instructions. Okay. Friday will be